Hello all, Aakriti Educations brings you the series of interesting questions on previous year Olympiad question. In this video, we will discuss one of the interesting question from AIME asked in 2019 in the field of algebra. The question says, there are positive integers x and y which satisfy the system of equations log x to the base 10 plus 2 times log GCD of x comma y to the base 10 is equal to 60 and log y to the base 10 plus 2 times log of LCM of x comma y to the base 10 is equal to 570. Let m be the number of not necessarily distinct prime factors in the prime factorization of x and let n be the number of not necessarily distinct prime factors in the prime factorization of y. Then we need to find the value of 3m plus 2n. Now we are given these two equations in x and y. So by taking the anti-logarithm both the sides, we will get x times GCD of x comma y whole square is equal to 10 raised to the power 60 and y times LCM of x comma y whole square is equal to 10 raised to the power 570. Now by multiplying equation 1 and equation 2, we will get xy times GCD times LCM whole square is equal to 10 raised to the power 630. As we know the fact that GCD of two numbers times LCM of two numbers is always the product of two numbers. So using this fact, we will get xy is equal to 10 raised to the power 210. Now, we also know that LCM is always less than or equal to the product of two numbers and GCD of two numbers is always greater than or equal to 1. So by using the fact LCM is less than or equal to product of two numbers, we will get y is greater than or equal to 10 raised to the power 150 and by using the fact GCD is always greater than or equal to 1, we will get x is always less than or equal to 10 raised to the power 60. So now we have got the three conditions that xy is equal to 10 raised to the power 210, x is less than or equals to 10 raised to the power 60 and y is greater than or equal to 10 raised to the power 150. So we can assume x in the form of 10 raised to the power k and it will give y is equal to 10 raised to the power 210 minus k. Since x is less than or equal to 10 raised to the power 60, so it will give k will always be less than or equal to 60. And of course, k will always be greater than or equal to 0 because both x and y are the positive integers. And this will also give 210 minus k will lie between 150 to 210. So using this fact, we will get GCD of x comma y as 10 raised to the power k because k is always less than 210 minus k. And LCM of x comma y will be 10 raised to the power 210 minus k. Now, by substituting these values in the equation 1 and 2, we will get k is equal to 20. And hence x is equal to 10 raised to the power 20 and y is equals to 10 raised to the power 190. So now we need to find the number of the prime factors not necessarily distinct. As we know that if any number capital N is of the form p1 raised to the power r1, p2 raised to the power r2 up to pn raised to the power rn in the prime factorization, then the number of prime factors not necessarily distinct are r1 plus r2 up to so on rn. And if we have to find the distinct prime factors, then of course they are only n distinct prime factors which are nothing but p1, p2 up to pn. But we are supposed to find the number of the prime factors which are not necessarily distinct. And hence, if we look in the prime factorization of the x and y, which are nothing but 2 raised to the power 20 times 5 raised to the power 20 and 2 raised to the power 190 times 5 raised to the power 190 respectively, then we will get the number of prime factors of x as 20 plus 20 is equal to 40 and number of prime factors of y as 190 plus 190 as 380. So the value of 3m plus 2n is equal to 3 times 40 plus 2 times 380 and this will give 880. Hence the correct answer is 880. Thank you all. If you find this video interesting, please like, share and subscribe our channel for more updates.